Let's start building the FlightSearch service. The FlightSearch service is a microservice within a flight booking system that facilitates the searching and retrieval of flight options based on various parameters. So the primary purpose of FlightSearch service is to enable users to search for flights based on specific criteria such as origin, destination, travel date, and the number of passengers. It acts as an intermediary between the user interface and the flight database, providing a streamlined and efficient way to query the flight data. This microservice is designed to interact with the MongoDB database to store and retrieve flight information efficiently. The flight search service ensures that the flight information retrieved from the database is up to date and reflect the latest availability. It considers factors such as seat availability, flight schedules, and other dynamic information to present accurate and real-time search results. For building the flight search service, let's go to this site called as start.spring.io. This is a Spring initializer website. So here we will first choose the option from the project category. For this project we are using the Maven project. We have option of Gradle as well. So Gradle will support two languages, Groovy and Kotlin. But in our project we are going with the Java project, not with the Kotlin and the Groovy project. And in the Spring Boot option, here we have three stable version: 2.7.13, 3.0.8 and 3.1.1. The snapshot versions, I will recommend don't use it because it is good practice to always go with the stable versions. So in our project, as I have mentioned, we are building this application for Spring Boot 3.0, so we are going with this option 3.0.8, and then we will define the project metadata. So inside this group I have given the id as com.techworld, and the artifact id is flight search service, name is flight search service. It is all most of the time same as the artifact and the name id. Description we can provide anything. I have given demo project for flight search microservice with a Spring Boot, and the package name. So the package name is the combination of group and the artifact id, and the packaging is jar. We can have the option of var as well, but we will be going with the jar option. And we also know that prerequisite for Spring Boot 3.0 is the baseline version of Java is 17. So we cannot use 8 or 11, we can either use 17 or higher version. But for our project I am going with the Java 17 version. Now let's add some dependencies. First we will add the dev dependency, dev tool. Okay, so this dev tool will help us to fast application restart. Then we will add the web dependency. Web dependency will help us to provide Apache Tomcat as default embedded container. Then we will add the Lombok, which will help us to reduce the boilerplate code. And then we will add the dependency as MongoDB. So for MongoDB we have two options: Spring Data Reactive MongoDB and Spring Data MongoDB. In our case we do not be dealing with reactive application, so we will go with the Spring Data MongoDB application. Then click on this generate option to download this project. Once you click on this generate option, you can see the flight search service.zip package is available. Open this file and copy this flight search service from here and paste inside your module flight booking system where we have already used the flight service. In the flight search service, now you can see the two modules, the flight search service and the flight service, which we have previously created. So now from this flight search service option, let's go to the source main Java and this application. We will try to run this application. And we can see the flight search service application is running successfully. Now let's add some configuration for MongoDB. So we can add this configuration in application.properties file. These are the configuration. Let's try to understand what these configurations are. Spring.data.mongodb.host, which we have given as localhost. This property specifies the host name or IP address of MongoDB server. In my case, the value is set to localhost, which is indicating that MongoDB server is running on the same machine as the application. The next configuration is spring.data.mongodb.port, which is equal to 27017. This specifies the port number on which the MongoDB server is listening for connection. The default port for MongoDB is 27017, and in our case also we are using the default value, that is 27017. Spring.data.mongodb.database, and this we have to define the name of DB. So we have defined the name as FlightSearch DB. This property specifies the name of MongoDB database to be used for flight search, and the flight search service will connect to this database to store and retrieve flight related data. If you want to do a local setup, you can follow my video series MongoDB Setup Complete Guide tutorial. It will guide you how to install MongoDB on Windows 11. It is same for other Windows machine as well as for Linux system. So I have developed around 9 videos which will help you to troubleshoot some issues while we are installing MongoDB, MongoDB Compass, and how to configure this as a services. Throughout the tutorial, we will dive into the logical architecture of each services, which includes controller layer for handling HTTP requests, service layer for executing business logic, and the repository layer for database interaction. We will be using MySQL and MongoDB database connections in our applications, and the message queue communication for specific services using Apache Kafka. In the flight search service, now let's create the packages. First we will create the controller package which will handle the controllers. Then we have the entity which is used for persistence of the entities. Model will be having the request and response object. Repository will be dealing with the MongoDB repository to persist the entity, and the service has the business logic. Let's define this class called as FlightSearchController.java. This is our class FlightSearchController.java. First we will annotate this with annotation called as REST controller to make this as a controller class, and we will define the mapping called as request mapping, and we will provide some value here. So we are providing the value as version as v1, and this is an API. And which API this is? This is a search flight API. So we are annotating this with search. And here we will define some instance variable. So we need the flight search service. Later we will see how we are implementing this flight search service, and we have defined one methods. So these are the API methods which will be getting invoked. So for our implementation purpose, I am just showing you one API, that is a get mapping for the flights. So we will get all the flights data as we are using the MongoDB. So I just want to highlight like how we are using the usage of MongoDB in our application. To inject the flight search service bean, we have two options. Either we will use the auto wire or we can use the constructor injection. If we go with the auto wire approach, there may be a chances that accidentally someone may modify this flight search service. But with constructor injection, we will be make sure that no one can accidentally modify this. So ideally going with the constructor injection is a better approach. So to make this as a constructor injection, we need two things. First we have to initialize this member variable with final keyword, and the second one is we can annotate this with requirement argument constructor. So instead of adding a separate constructor who will take these parameters and do the assignment, we can skip this step using the requirement arg constructor provided by Lombok. The flight search service is always in sync with the flight module to get the latest data of the flights. Currently, I am not going in the implementation like how the flight search service and flight service will be in syncs. We have several operations to make this databases sync. So this is beyond the scope of our code. So I am just going to show you the usages of Mongo repositories and the Mongo usage, how we will implement in our application. We will define a method called as search flight. This search flight will be annotated with get mapping, and the endpoint for this one is /flights. Here it will consume the flight search request. We will see how we are constructing this flight search request, and as a response we are getting the flight search response. So based on the given request we will get the list of flights. So we will get this response in the flight search response object. And to implement this from the controller layer to service layer, we are using the flight search service. So this flight service will call the search flight method. Inside this model package, we will define a class called as flight search request.java. This class is a Java record called flight search request. In Java, records are a concise way to declare classes that are primarily used to hold the data. They automatically generate useful methods such as constructor, getters, setters, equals, hashcode, and toString method based on the provided field. The flight search request record has 4 fields. First one is the origin. This is a string representing the origin of the flight. The next is the destination, a string representing the destination of the flight. The third is the travel date, a local date object representing the date of travel. And then last one is the passengers, an integer indicating the number of passengers. By using the record keyword, the class automatically generates a constructor that accepts the value for all the fields, getter method for each field, and the default implementation of equals, hashcode, and toString methods. Records are often used for immutable data objects such as representing request or response in the API communication. They provide a concise and convenient way to define such data classes without writing boilerplate code. Now we will see the flight search service implementation. I will come to flight search response.java class later. So first we will define this interface called as flight search service. And here we have defined this method called as search flight, which will take the input parameter as a flight search request, and it will return the list of flight search response. Now let's see the implementation of this class. So the flight search IMPL class will implement the flight search service interface, and we will annotate this class with the service annotation. And here we will define the repository called as flight search repository. And we again have a two option, either we can go with the auto wire or we can go with the require arc constructor as we have seen previously. So I am going with the require arc constructor, and make sure that you are using the final keyword here. Now first we will try to see what is the flight search service repository. Inside this repository package we will define the interface called as flight search repository.java. So this interface will extend the Mongo repository, and it will accept two parameters. The first parameter is the entity which we want to persist, and the second parameter is the primary key of that entity. Now we will see how we are using this flight implementation. So the flight class is defined in an entity package called as flight.java. As we have seen in the flight service, we will be using the entity annotation to annotate this class for persistent. But with MongoDB, we have to use the document annotation. Along with that, we have seen that the flight class we have used previously as a class. So we can use this class as a record if we are sure that we do not want to use this class for any of the bnutil.copy properties or any of the reflections, right? So in such scenarios we will go with the record class. As we are using a simple example here, so I am going with the record options. So this is a Java record class which is annotated with a document annotation, and it will use the input parameter as collection equal to flights. So which is a MongoDB specific annotation from a framework like Spring Data MongoDB. It indicates that the instance of flight class will be stored in flight collection within the MongoDB database. The flight record has several fields. The first one is the ID, which is the identifier for the flight, and it is annotated with the ID called as @ID, which is of type long. The flight number, which is a string representation. Then we have origin and destination. Departure date, that is a local date object which is representing the departure date of the flight. Similarly, we have the arrival date, and then the amount, which is representing the cost for the flight. The total seats, which indicates the total number of seats available on the flight, and the available seats, which indicates the number of seats currently available on this flight. And by using this record keyword, the class automatically generates a constructor that accepts the value for all fields, getter method for each field, and the default implementation for equals, hashcode, and toString methods. Now we have understood the flight search request, and the flight search response objects. Now we will go to our implementation logic, and then we will move back to the flight search repository to understand the implementation as well. Inside this search flight, we will invoke the flight repository to get this method. Now let's first understand what this method is. Okay, so let's first go back to the flight search request. What we have seen is we have 4 parameters: the origin, destination, travel date, and passenger. Right, so the user wants to query based on this parameter. So in our database, what we will do, we will try to find out from the DB. We have like flight number is there, origin is there, destination is there, but we do not have anything called as travel date, right? If we see here, inside this entity we do not have anything like this. The search flight method is the main logic of flight search IMPL class. It accepts a flight search request object as a parameter and return a list of flight search response objects. Inside this method, flight search repository is used to search for flights based on certain criteria such as origin, destination, departure date, and available seats. Find by origin and destination and departure date greater than equal and available seat greater than equal method is likely a query method provided by flight search repository interface. You will be surprised what a big name we are using for our repository to search in a specific method. I have used this thing to make it more simpler. Here, as you can see, we are using 4 conditions. Let me explain you all these conditions. If we can see in our request, we have 4 parameters: origin, destination, travel date, and passengers. So we have defined our flight collection, right? So here in this flight collection, we can see we have an option for origin and destination. We do not have anything like travel date. So how will we calculate the travel date? We will do the comparison from departure date. If the departure date should be greater than or equal to travel date, then we will display that data. Along with that, for the passengers, so for the passengers we will try to first find out how many available seats are available. So let's say in our flights we have 250 seats, and out of that 200 seats are booked, so only 50 seats are remaining. So we will get this information from available seats, and the number of passengers in our request is 3, so 50 is greater than 3. So this is how we will satisfy this condition. Flight search repository is extending the Mongo repository, and this Mongo repository is a Spring Data interface that provides generic CRUD like create, read, update, and delete operations for MongoDB. So for defining our own methods, we have created this method. This method is used to search for flights based on various criteria. This method name follows a specific naming convention that Spring Data understands. It combines various properties and conditions to generate a query. In this case, the method name implies that it will find the flights with specified origin, destination, departure date greater than or equal to given date, and available seats greater than or equal to given number of passengers. The return type of a method is a list of flight, indicating that it will return a list of flight objects that match the specific criteria. Behind the scene, Spring Data will analyze the method name and automatically generate a MongoDB query based on the provided criteria. This allows you to perform database operation without writing the explicit query code. If you wish, you can define your own criteria and specific query to write this specific method. Now you have understood the power of Spring Framework. How easily we have defined the 4 conditions in just one line of code. Otherwise, we could have to write the criteria and the query to specifically implement this feature. There is one important thing to be considered. For example, once we are defining the field name or property name, for example, origin. So if you see here in the flight entity, this is starting with the small letter, right? Or everything is in a small letter. But once we are defining this in repository by invoking any of the field, we have to make sure that the first letter is always capital letter. So for origin it is capital, destination it is capital, departure it is capital. Also we are using the AND condition. So this AND also A should be capital. Similarly, for greater than, G should be capital, then T should be capital, equal, E should be capital, and so on. So we have to use the camel case. Now let's go back to our flight service IMPL class with our search flight functionality. So now the retrieve list of flight object is transformed into a list of flight search response object using map to flight search response method. It uses a stream API introduced in Java 8 to perform a series of operations on flight list. First, we are using flights.stream. This will convert flights into a stream, which is a sequence of elements that can be processed in pipeline. Then we are calling the map method, and inside the map method we are using the reference method using this annotation, this colon map to flight search response. This is a mapping operation that transforms each flight object in the stream into a flight search response object using map to flight search response method. This is a private method which is a helper method we have defined in our class. Then we have a collect method, right? So this collect operation, what it will do, this collect will transform the flight search response object from the stream and collect them into a new list called as flight search response. The collectors.toList method is used here to create a list from stream elements. Finally, the resulting flight search response list is assigned to a variable called as flight search response list. The map to flight search response method is a private helper method that takes a flight object and maps its property to a new flight response object using bnutils.copy properties. This method facilitates the transformation of flight object into the flight search response objects. So the flight search response class we will define in this model called as flight search response.java, and as you can see we have defined this class as a class not using the record annotation because we are using the bnutil.copy properties, and it will use reflection to copy the data, and we cannot use any of the reflection with the record classes, so we have to make sure that this class should be a normal class. So once we are using this normal class, we have to use some annotation. So we are using the data annotation to generate getter and setter, all are constructor to generate all argument constructor, builder to define a builder pattern, and no are constructor for no arguments, and the fields are same as we have seen in our entity classes. In our previous module called as flight module, we have covered global exception handling. This is very important to avoid the big message, and we can get some specific message in case of any of the condition. Along with that, we have seen the use case for custom exception handling. So for example, if flight is not found, we can throw a specific message like record not found and so on. So 404 exception we can throw. In case of generic, we can throw the 500 internal server error and so on. So I am not covering these things again in the same module, but I will recommend that you will implement all this functionality in all your microservices. With this thing, our functionality is ready. Let's quickly recap what all things we have done. First, we have defined the controller layer. Inside the controller layer, we have defined a class called as FlightSearch controller.java. It will communicate with business layer using the FlightSearch service. So the FlightSearch service we have defined as a constructor parameter using the require ask constructor, and we have defined one mapping. So this is our API, and this API will be having a method name called as search flight. The search flight will take input parameter as a flight search request, and it will return a list of flight search response object. So to communicate from the controller layer to the service layer, we are using this flight search request, and this flight search request will be passed to the business layer, and the business layer will return a list of response. And here we are using the http status.ok so that the request is completely fine. Then we will move on to the flight search service. So here we have defined the interface, and we have a implementation for this class, and here we have write the business logic for the search flight functionality. So the search flight class will be using the flight search repository to query the data from MongoDB repository, and we will be doing this based on certain parameters. So these parameters we are defining, and for this we have write a specific method inside the flight search repository. So this repository will be serving the 4 condition. As we have seen, it will be querying based on the origin and destination. These are the 2 condition. Then the third condition is departure date should be greater than, and the fourth condition is available seat should be greater than and equal to passengers. So these are the 4 condition we have seen, and with this 4 condition our method is ready. Moving on, once we are querying for this request, we are getting the list of flight object. Then we are using the Java Stream 8 API to do some processing, and we will collect this request from the transformation. So the flight object is transformed into flight search response object. For this we are using a utility called as beinutil.copy properties. Okay, and now we will quickly see how we have implemented this request. So inside this entity we have defined a flight which is using a document annotation to define this collection, and here we have defined some parameters. Along with that, this is a flight search request, so we are using this as a record classes, and here we have defined this 4 parameters. And inside the flight search response, this is a replica of flight class. Only difference is we are using for flight record. In some cases we will use in the entity classes or in the persistence classes as a class or record depending on the requirement. And the response class is same as the flight class, and it will provide all these 8 parameters. To initialize the sample initial data for flight search, we will utilize a command line runner. Command line runner is an interface provided by Spring Framework in Java. It is used to indicate that a class should be executed when the application starts from the command line. This class serves as a data loader for flight related data. It is responsible for populating a database with sample flight data. Let's go through the code step by step. We have defined this class in a package called as data loader, and there we are defining this class with name flightDataLoader.java. It implements the command line runner interface. This interface allows the class to be executed automatically when the application starts. This class has a constructor that takes FlightSearch repository object as a parameter. The FlightSearch repository is a dependency required by data loader to interact with the FlightSearch data store. The run method is an overridden method from the command line runner interface. It contains the logic that will be executed when the application starts. Inside the run method, the existing flights are deleted from the flight search repository by calling the delete all method. This step is optional and may be used to clear any existing data in the repository before loading the new data. After that, we will have three sample objects which are created. Each object represents the flight with specific detail such as flight number, origin, destination, departure date, arrival date, available seats, amount, and other attributes. Finally, the sample flight objects are saved to the database using save all method of flight search repository. The arrays as list method is used to convert the flight objects into a list before saving them. With this, now we have some initial sets of data. Now let's run the application again. The application is up and running. Now we will use the Postman API to hit our API. For that thing, we need to configure our Postman with HTTP localhost, and the default port is 8080 with this request mapping /v1/api/search with the flight option. So this is a Postman. Inside this Postman, I have defined a collection called as search flight, and I have defined this request called as get search for all flights. So here, as we have seen, so this is the our search request, right? So it is http colon localhost 8080 with this request mapping parameter and the get mapping parameter. Then we have to define this body. So inside this body, you have to choose the option as raw and choose the data type from here as JSON. Once you do this, we will configure this property inside this curly bracket, open and close curly brackets. Okay, so let's see what are these properties. So these properties are same as we have defined in the flight search request. So if you go here inside this flight search request, copy all these four parameters and provide some values. So we are providing the value for origin as Dubai DXB, for destination it is Switzerland, travel date is 19 June 2023 and number of passengers is 1. Now let's hit this request. This is the response we have obtained. We can see inside the pretty or inside the raw section. The raw sections, it is quite difficult to understand, so always choose this pretty option. And inside this pretty option, you can see this array. As we have seen, we have defined only 2 entries in our data. We have defined 3 entries, not 2 entries, right? You remember? Inside this data loader, if you see, here we have 3 entries. But if you see the condition, what condition we have given, the travel date should be 19 and the number of passenger is 1. So this will get us the data which is greater than 19. So if you see here the departure date, we are getting the data for 23 June and for the 22nd June. And if we go inside our flights, we can see we have initialized 3 dates here, right? The first one is 23 June, second is the 22nd June, and the third one is 25th June. But the location what we have decided, origin as Dubai and destination is Switzerland. So if we see here, for this Dubai location we have only 2 entry. The third entry is India, so that is the reason we are getting 2 records. And the number of passengers also, if we see, so the seats available are quite good, 130 200, right? So that is the reason we are getting this detail. And Along with that also, like if you see the destination is different for the third request. For both the requests, the destination is Switzerland and here the origin is Dubai. So this is the reason we are getting these two records. In the MongoDB Compass, now we will see our entries and the flight database for this collection flights. So let me go here and connect to this application, and you can see here the FlightSearch DB database is available. As we have seen here in this application.properties, we have defined the FlightSearch DB as a database name. Inside this FlightSearch DB, we have a collection. Okay, this collection name is flight. So if you click on this one, here we can see there are 3 collections as we have seen in the data loader. Right, in the data loader we have defined this 3 collections. So if we see here, this ID in our MySQL database, it will come as a normal ID, right? But here it will come as underscore ID, and along with that it will add one more extra parameter called as underscore class. So this underscore class will come with fully qualified name, as you can see here, and the other details are same what we have added: flight number, origin, destination, departure date, arrival date, amount, total seat. So we can see the 3 records here. That's all for the FlightSearch service module.